Well, welcome everyone to the Thursday afternoon digital engagement session. Congratulations for making this far. You've watched a lot of presentations up until now. Hopefully, you've still got some enthusiasm for what we have to talk about here. I think we've got a couple of exciting things lined up for you guys. We're going to start off with Mike Staley talking about the FIA Big Map free speeches above ground biomass layers, which we are very pleased to finally announce are available. After that, we're going to move to Cara Leitheser, who's had been working with us, but recently took a job with Tacoma County, has agreed graciously to do an encore presentation to talk about her work on the FIA DataMart and Geospatial showcase. Then Rebekah Zehnder joins us from Texas A&M Forest Service to give us a live demo of the Urban Forest Stats app. Then I'll be giving a demo about spatial intersections with the FIADB-API. And last of all, but not least of all, Alex Young from the University of New Hampshire is going to give us a demo of accessing urban inventory data from the FIADB API using R. And I think there's a spatial component to that one as well. But without further ado, I'm going to hand it off to Mike and get us going.
All right. Hey, my name is Mike Staley. I'm actually a contractor here. I work with Oak Ridge Associated Universities, and I work with Jim Garner in the St. Paul office of the Northern Research Station in the FIA program. My role in this effort is to create tools and guides to help use FIA Big Map layers, which is what I'm going to show you today. I'm going to do basically break this presentation up into three parts. One is how the FIA Big Map layers were created. Then I'll follow that up with how they were assessed to determine confidence in them. And then lastly, how to access them. I'm going to try to get through those first two pretty briefly, partly because Ty, you just heard Ty's voice on here, did some in-depth stuff on how the layers created and how we assessed them. I'll touch on those as fast as I can to give my the folks following me some time to do their thing. So this is a live Aboveground Biomass 2018 from the FIA Big Map project. These layers, all the layers I'm going to show you today were created by using Landsat images and more than 200,000 FIA plots. The image we're looking at right now is a 30-meter pixel spatial resolution raster, and all this raster happens to have the extent of the coterminous United States. Each pixel in the images I'm going to show you today are going to have each pixel represents tons per acre. And darker in this case is more biomass, and lighter is going to be less biomass for these images. This is sugar maple. There are 327 individual tree species in the Big Map 2018 portfolio. We have some other than Aboveground biomass, we have some other mostly stand-based metrics layers, and those are in the FIA Geospatial showcase. I'll touch on those briefly at the end of the presentation. This is white oak. We used imagery and plot data collected between 2014 and 2018 to create the layers that I'm going to be talking about today. So that's the time period. And we should begin work shortly on the 2016 to 2020 period. And then I think the idea is to create, maybe backcast some other 5-year periods over in 2025. So if you zoom in a little bit, this is out in the Cascade Mountains in the northwest of CONUS. The 30-meter pixel resolution is pretty amazing. If you take a pretty good look at this image, you'll see it's picking up on elevation changes. You can see in the darker areas here, higher biomass values, and at the lower levels, you see some lighter biomass values as well as at the higher elevations. You can also see this clear-cut pattern, right? All these square areas. So the model's picking up on that, as well as on hillside. What am I trying to say? Aspect, sorry. And riparian areas, you can actually see some differences at this 30-meter pixel resolution. The really interesting and exciting thing about Big Map, FIA Big Map project is the number of layers, species that we're going after. We have, again, I mentioned this before, but 327 tree species in this effort. uh, observed on, and they were all observed on FIA plots. Those are what's involved in the modeling effort. We also summed all those values up, 327, into a total live above gross biomass layer. So in total, we have 328 layers. So how was this done? I'd like you to take a look at, if you get the chance, and maybe this will be in the future, look at Ty Wilson's presentation earlier, just at like 12:15 today. He talked about this in more detail, but he led a team in partnership with Esri to go through these 36 eco-provinces that cover the coterminous United States. The team pulled together Landsat images between 2014 and 2018 for each of these eco-provinces. If you're not familiar with Landsat, it's a low Earth orbiting satellite system run by the USGS, and that's the satellites, the Landsat satellites actually cover every point on the Earth every 16 days. So this is really big lift number one for the project. Using the Esri's cloud processing environment, the modeling team first created time series stacks, the upper image, and then drilled down through each one of those stacks. So with all those Landsat images, they basically drilled down through each pixel to create pixel trajectories for every pixel location. Once they had those pixel trajectories in hand, they actually were able to glean spectral information from each pixel location, as well as phenology, basically pixel changes throughout the year and over time. And then the last thing they did was they created these harmonic regressions to model those pixel trajectories and relate other pixels that were associated with FIA plots. So the second big lift for this project was to take those trajectory models for every pixel. The team identified pixels that were at FIA plot locations. They used the the K nearest neighbors model or algorithm, so KNN algorithm. They used the trajectory models along with some additional predictor data sets, the ones up here, phenology, precipitation, temperature, location, topography, and ecoregion, to associate each pixel with a pool of the most similar plot location pixels. That way, every single pixel is associated with a pool of the most common plots, which were available in FIA measured values, can be summarized and applied. When all the ecoregions were mapped, the team mosaicked all those images together to get continuous data sets for each of the 327 species. For more information about this, for more detail, again, reference Ty's, Barry Wilson's presentation. I believe it was an Embracing Cloud Computing for FIA operations session a little bit earlier. He talked in depth on this. So we're going to talk about validation. I mean, how do we know how good the FIA Big Map layers are? We really want these things to be used for analysis and decision making. So to validate the model estimates, we used the EPA EMAP hexagon grid, almost 13,000 nearly identical hexagons that span the whole country. Each EMAP hexagon contains about 20 FA plots on average, which is enough to produce statistical estimates with some reasonable confidence intervals. Also, the FA plots are already attributed with the EMAP hexagon codes, so it makes it convenient for a convenient sampling network for generating comparative estimates. So each EMAP hexagon within a given species range, we compared the FIA plot area estimates to estimates based on the model values that we got and sampled at FIA plot locations. Both estimates are sample-based with identical sample sizes, so we're really comparing apples to apples. However, we are not comparing FIA plot estimates to the sum of all the pixels within each of these hexagons. So this works pretty well when you're looking at all species combined within a hexagon, like total above ground biomass, for example. But it also holds up when we're looking at more common species, such as white oak, just showed earlier, generally have plenty of plot data at this level, especially at the heart of the range. The less common species, you start to see fewer plots to play within each of those hexagons. So confidence intervals start to get stretched out a bit. By the time we get to rare species, it becomes nearly impossible to generate an estimate with any kind of confidence. So what to do? Go up to aggregate 7 hexagons. And so we're basically adding on scale here to get a better assessment. At the 7 hexagon aggregation level, it definitely helped increase the sample size for even less common species. There still really aren't enough, though, samples for the rarer species. So in that case, we got to go up to 49 hexagons. So grouping again, first was 1, now we went to 7, now up to 7 times 7, 49. In this case, it really helped pick up some of the rarer species with adequate sample sizes. So that was kind of the idea, and here's actually what we generated. So these are, we have layers for those 3 levels, 1, 7, and 49 hexagons for each of the 237 species plus total. In this depiction, we're looking at loblolly pine down in the south, and the orange-brown hexagons are areas where the model is overestimating, if you will, in this hexagon areas. The blue-purple hexagons were underestimating. When I say overestimating, underestimating, I'm talking about confidence intervals. Overestimates are outside of the 90% confidence interval, and underestimates are below the minus 90% confidence interval. There are also some gray shaded areas here. And that's really the sweet spot. That's where confidence intervals are between negative 90% and positive 90%. And again, this is a level 1, we'll call it 1 hexagon aggregation. This is a 7 hexagon aggregation for loblolly pine, same species. Here, just wanted to highlight a couple other things. Again, we talked about the orange and the blue, but outside that orange and blue are these lighter grays and even white. The light gray areas are where the plot and the model agree that there's 0 above ground biomass in this case, and the darker gray talk about the plot is 0, but the model has actually has a above 0 estimate, generally close to 0. But again, a little bit of disagreement here, a little bit more agreement on these lighter gray ones. And then there's some white areas on the edges where there was insufficient plot data to determine the confidence interval. I think you'll see those in our demonstrations maybe later. They'll actually be transparent and or white. So that gets us to 1, 7, and 49. So here's 49 hexagons for loblolly pine. And I don't know if you noticed over the last 3 slides, but there seems to be an increasing underestimate as you get to this 49 aggregation level when compared to 1 and 7. So each one of those hexagons, we created some plots, and so we put all those hexagons for each plot for each level on this chart in the symbology that we used on the map. So this one is for this is a scatter plot. It includes summary statistics up on the upper left-hand corner. The one-to-one line you can see there, an RMA line to give you an idea of how close that is to the one-to-one line. But you can, in this particular diagram, you can see a little bit of an overestimate on the low end. The orange hexagons are closer, or overestimate, I should say, and then the blue hexagons are an underestimate. Again, this is loblolly level 1, so the 1 hexagon aggregation. Another chart we created to try to describe what's going on is a chart sorted by the plot means for each of the hexagons, so increasing from lower to higher. We also included a mean plot line, that's the black line. So that's a mean plot values for each of the hexagons. And again, you can see an overestimate in the low end of the plot values, if you will, plot estimates, and an underestimate in the higher plot estimate values, hexes. So that was kind of just a summary of what we see, the actual layers themselves that are created, and then how we assess them using the hexagons. But we get asked a lot, like, okay, that's great, but how do I get my hands on this data? So Now actually just this week we made the FIA 2018 FIA Big Map layers available to the public, and we have two options. One is the one you're seeing right now is actually the raster data gateway. It's USDA Forest Service publicly available site. You can actually download. Oops, I'm so sorry. You can actually download. I'll show this in a second. Any one of the 328 layers with GeoTIFF and with validation data in it. If you want to get right to the data, you can go to actually through to AGL, America ArcGIS Online. We have an image service available for folks that want to go directly to it and get it that way as well. I briefly mentioned at the top of this talk about, I've been mostly talking about above ground biomass layers. We also have other layers. Again, I mentioned those were stand-based metrics. So forest type, stocking level, stand age, lorries heights, stand size, total carbon and carbon pools, and then site productivity are available on the AGOL Geospatial showcase. I'll try to put a couple of these links out for folks to get at this data as we go on here. And then the last slide, and then before I jump off into, if I have some time to show some of these sites, we put together story maps with information on the background of FIA, the FIA Big Map project and how we got here, some more information, plus species gallery, data access, workflows, assessment layers, and then a dashboard, how to use a dashboard. If I get a second, I'll even try to show a dashboard real quick. So if I have some time here, where we at?
Mike, why don't you go ahead? I think we're doing good on time.
Okay, I'm going to share out. Let's stop sharing for a second. Oop, nope. Yeah, here we go. Hopefully this is what I'm after. All right. Hopefully everybody can see. Browser with this is the Geospatial showcase. 8 image services, if you will, available for all those forgetting the words I'm looking for. They're not above ground biomass in this case. I'll get to that in a second. So these are stand-based metrics, and you can just go through and actually use these, get access to the images, services, whatnot, right through the Geospatial showcase. This will take you off actually to the image service itself. I don't want to get into details too much of how to use that. Taking a little bit of time. Let's give it a second here, see if it comes up. And if not, I'll jump over here to the showcase. So just this week, we put out onto the Geospatial showcase the 328 zipped rasters with their assessment data. And here they are down below. Again, a download to actually just download these guys and provide a checksum to make sure it hasn't been tampered with or it is what we expect it to be. I can't remember if I put actually right here, just to give you an idea of the size of these things. The largest one on the Geospatial showcase, or the zipped up versions, are over, I believe the total is almost 15, not quite 15 gigabytes, and I think the top 1/3 of them are above 1 gigabyte. So they're relatively big rasters. Take a little while to download, but once you get them, you'll have them. And there's GeoTIFFs and shape files with the aggregation, or sorry, the assessment data. The story maps, if I can take a quick second to run through the story maps that we have, we put together a collection of story maps. These 6 story maps. First one with background. Again, just by clicking on them, you can get to them with background. All 6 of them will show up in the outside of the collection. But this talks a lot about how Big Map was created. Again, a little bit of what I touched on and what Ty Wilson's discussion goes into. Gets into some of the details of how the Big Map data was created. I should want to jump over here to this guy. He's already loaded up. So the second thing was the species gallery, which again, we put all 328 layers in here from total. These are all sorted, I believe, by genus species, but you can display them, and it gives you kind of an idea of, you can go in and look at them, and then combine them. But that's about all you're going to be able to do with this particular app. Jump over to, yeah. So it's background, species gallery, data access layer. I've got this one loaded up here. No, it just wants to play by itself. Apologize for the delay here. So data access layer is going to get into really a lot more, again, about the big map layers themselves. Talk about how we can get to them in this case. And again, this will be the image service that you can get to. If you want to dig into it that way, you can also just get an image up on from the image service itself. You can actually bring an image up and start to explore the data using the image service and the AGOL item. You can also do all this through ArcGIS Pro. Bring up any of these layers through ArcGIS Pro. This gives you an idea of how to get access to them through that image service in ArcGIS Pro and start to load them up. You can, and again, you can, in addition to downloading the rasters through the gateway, you can actually download portions of them through the image service in AGOL or ArcGIS Pro. Or if you had a study area, for example, you could go to a study area, identify, say, a polygon, and then get the extent of that polygon, and then actually go after those images and download them. Some workflows put together, just some very simple workflows to give people to get going on this. One of them was proportion, so you can take any species and find the proportion to total, for example. Provide some Python to go with this. You can use a notebook to run this. Just note that you're going to have to have the spatial analyst license to do that, to be able to run these guys. So the first one was just, again, or one species to totally get proportion. And with the same idea, you could do two species to using some Python to go get those. Now, just one note, you'll have to actually have these study areas downloaded in TIFF format, GeoTIFF format, or TIFF format to be able to do this, use this workflow. And then finally, combinations of those two, just using a sum of some species and getting a proportion to total using already some of the information above. The assessment layers, just a real quick guide on the assessment layers again, talking about the hexes, all the stuff I just talked about in quite a bit of detail. 3 visual components, 3 different ways to look at the assessment layers, one on the map. You can get it, gives you a feel for the levels, describes each of those get created and how they get used. Oops, I need to go back here just a second. That's just one of the 3. So map based. The other was again a little bit of the symbology on color schemes and confidence intervals. The second visual component was using the 2 charts that I showed earlier, the scatter plots. Just gives you an idea what the scatter plots mean. And lastly, and there's some examples. And then lastly, the plot means, again, describing what they are and how to use those. The last story map was on dashboard. Used Experience Builder to create an app where you can go in and take a look at all these layers and with the assessment layers together with the raster. So this story map is going to go walk through that. I won't go through this all in great detail, but the dashboard has a splash screen, just gives you an idea of some information, get it out of the way so you can start doing your work. You can have a selection area for year, species, a common name actually, and what level of assessment you're interested. Once you get that, you load it up, and then you can get some things on the map. You can also do a little bit for common name, which species you're interested in, and then load it up. Then to review once you got a species or a common species loaded up, it'll kind of walk through each of these 3 information areas, tell you a little bit more about the raster itself and the assessment layer. The layer controls kind of map-based stuff too. How do I turn on and off the layers? how do I use the transparency, that kind of thing. A little discussion on the charts themselves again. Each of the charts, when you click on it in the tool, will give you a full resolution version in a new tab. And lastly, using the map. I'm sure most of the folks that are familiar with ArcGIS or HOL or Esri products are going to be able to use this map, no problem. It's pretty standard stuff. And then a little bit on this drawer up at the very top, just some other options that you have to do some things. See that, make that thing pop up. There it is. There's the drawer up in the upper left-hand corner. Jim, I don't know if I have enough time to go into the dashboard itself, because I do want to honor the time for everybody else here.
We should probably get into it.
Yeah. So, you want me to call it quits, or do you want to keep going?
Well, any last thoughts, I guess?
No, but if I'd love to get some feedback on all these things for sure. Again, they're all going to go live. I think the dashboard is the last thing that's going to go live. Everything else, the story maps are live already. You're able to download on the raster data gateway. Yeah, and the image service is live too. So, yeah, any information, feedback we can get, I'd love to have it.
We're just hoping to get this validation dashboard pushed out. Hopefully by the end of the week, we're working with the CIO server admins to get that loaded onto the server. So yeah, hopefully that'll be soon. Really excited about this new data set. Thanks, Mike. I can't wait to see what people do with this. I'd like to direct any questions right now to the chat. We'll try and keep an eye on that. If you have any questions for any of the presenters today, yeah, please dump them in there, and we'll see if we have time at the end to address all those. Otherwise, we'll try and address them in the chat. That said, moving along here, I'd like to move on to Rebekah. Cara Leitheser is now going to talk to us about changes and updates she's made to the FIA DataMart and the FIA Geospatial Showcase. Take it away, Cara.
Thanks, Jim. Afternoon, everybody. We're going to back up a little bit from what Mike was talking about to more of a general where can you find data, what's new, what's the digital engagement group doing. Some of this is going to be review for folks. This has been around for a while, but there's been some updates to both the DataMart, to the Geospatial Showcase, highlighting some of the new stuff, as well as highlighting some of the things that have been pumped out in really, what am I trying to say? Collaboration between different groups. So there's a new landing page for the DataMart. It's combined with the NFI and the Urban DataMart now in one dashboard. They look similar. There's a few changes, including how do you use this application that'll walk you through how to use it. There's a new DataMart version tracking, so you can see what the date, what FIADB version there is, what the version of the DataMart is. This was an asked for feature that we were able to add. So if there's things, feedback is appreciated. So if you're using it and you're looking for something that's not there, please reach out, because it may not be able to be added exactly as you want, but we can add whatever the user wants to the DataMart. So here again, instead of looking through all the tables and lists, we've brought it down to what was the most recent year in the FIADB, so that you can quickly glance and say, okay, Alaska was 2020, instead of having to go through drop downs and things like that. The data available for download is similar to how it's been for a while. You just select your state. The map is not selectable. That long story, with the product you can't. So or with the product as it's set up, you can't. So you select Arizona, zooms to Arizona, say we want the CSV, all the different CSVs will pop up here. Also SQLite, that'll also pop up here at the bottom. Additional things here, the log of what's going on. If there's something not working, you can see what's happening behind the scenes. and then some entire database stuff instead of breaking it out by state or geography. And then new added just recently is combining the earth into the same, dashboard frame. Same thing, we've got a map base here. The legend here shows what cities are available, what data is available, what cities are in progress. If you want to filter here, you can do the same thing. So say I want to know I only want to look at data available, and let's look at Madison, Wisconsin. So then it zooms in, you can see again, here is the legend. So you can see the red is the urban project. The light blue is the urban project within the CBSA. Dark blue is outside of the CBSA. Then over here to the right, you'll see the project information, key statistics that are important, as well as options to download the CSV or the SQL down here. And then there's also a link here that says to view entire project polygons, click here. This brings you to the AGOL directions page, or it gives you a description. You can open them in the map viewer. You can bring them into your map. They're called Inventory 2024. So if you are in Pro, you can also download them through Pro into your map. And that talks about, that's right here. That's what this says, shows you how to do that. I'm going back here. This is similar. This links to the FIADB which Jim will talk about. And this newly links to urban forest stats, which Rebekah will talk about. So I won't touch on those. At the top, you'll see this little caret where you can go to different pages, the FIA homepage, the FIADB documentation, some data and tools, things like that. The Geospatial showcase can also be got to from here as well. I have it open. Sneaky can go here. This also looks very similar to what it has been. Mike showed you the Big Map layer catalog, so you can find that here just by scrolling down a little bit. DataMart, iTree, My Cities Trees, things like that, the one-click fact sheet. One project that I want to highlight that was recently published between Rocky Mountain region and NRS region was this forest carbon and above ground biomass dashboard. We took a look at the database, pulled the data out and created this dashboard with the top 5 trees in each state. So you can take a look at whatever state you want to. We're in Minnesota, so we'll click that. Map zooms, the chart, and all of this stuff is interactive. So it all changes on the fly. And so this was done with some winter workers that wanted to learn a little bit more about AGL. So we got together and worked on this project. Another thing you can get to from the Geospatial showcase from this drop down here is an effort by the NRS to do 5-year digital reports mandated through the Farm Bill. We have to do 5-year reports every year, or every 5 years. And so we've made this dashboard showing which ones are completed. You can get to the actual 5-year report here, like the Big Map one that Mike was just showing. They are a story map collection, so you can click on all this stuff, get to it right from here. You can also click on it and get some quick information. Is it done? Here's when it was completed, things like that. There's also a FIA in context map here, basically showing how FIA works, what do we do here, about the, you can see all the different things we do here. So you can see that down at the bottom of that page. And then something that we've taken on an effort moving forward is to build out our content library on the Geospatial Showcase. The goal is to make it kind of a one-stop shop where you can, kind of like the pub search, where you can go and you can look for a specific thing or some data or some, I don't know, anything FIA, I guess. And to get to there, you click on these three little, this little hamburger menu here, and you can click on any of these. It'll all lead you to the same spot. So I have that open here. And so that'll pull up something that looks like this. You can see the data, documents, apps, and maps, like in the previous, well, right here, you can see all those the same. And this is just anything that's available to our organization. So, this has to be added. So this is an effort that is being undertaken, and it is kind of a big effort. So it'll be changing. There'll be more added. But it's really slick. You can search for things here. So you can search for things here. You can filter here the types. You can filter on tags, and you can filter on all of this stuff. But say I want to look at only urban. Let's see if there's any. So there's one for urban forest monitoring. I can filter that, and here we have urban forest stats. That's been tagged as urban. Let's say we want something with wood. There's all kinds of different things that we're tagged. It will search for both the title and in the tags, and you can see the tags right here. So this has been started. It was started through the NRS ASG group, and so they have been slowly working on that. But in order to get those have to be added when things are published. And so if you have a publisher capability through AGL, when you publish, it'll ask you for, the title, the description. If you can add the tags in that publish box, they can be then searched for. So this one has tags: FIA, big map, wood, movement, flow. You can read the rest. And to find those tags, there was an effort between the AGOL admin group, the NRS ASG group, to come up with a list of tags. And so it's a working draft, I think, but something that we can reference to add the tags. And then eventually, once we get more of these things in there, it'll become a bigger and bigger and more robust library where you can reference. Oops. And I think that was it as far as the updates that have been added. I'll open it up to questions, and if not, I will pass the baton to the next speaker.
Awesome. Thanks, Cara. Yeah, any questions for Cara? If you have any questions, let me know, or enter them in the chat. Would like to highlight there the tags effort that Cara was kind of pushing and helping to co-spearhead when she was working with us here. If we can continue to add tags to apps as we develop and publish them, it's just going to make our content a lot easier to get to. So yeah, I think if you want views, add tags. Right, find what we're looking for. All right, with that said, moving right along, we've got next up is Rebekah Zehnder to show off her brand new fancy urban forest stats.
All right, good afternoon.
So I am Rebekah Zehnder. I work for the Texas A&M Forest Service, and we have been partnering with FIA. Anyway, Urban Forest Stats, I'm going to give you a live demo, even though I know how live demos go. And it's just a brand new tool to access urban FIA data, so I'm really excited to share it with you. It just launched this week. So Cara, I am so impressed to see that it is already linked in places. I gotta go check that out. But that's very, very exciting for us and hopefully for users of FIA data too. Okay, so to get started here, you see the screen. I put the link in the chat too if you want to try to follow along, or if you want to explore later. You can do that. You don't have to scramble to try to write down the URL. Our goal here was really to reach a new audience of potential urban FIA users, our urban and community forestry practitioners. And so they don't have the FIA background. They don't know anything about FIA, but they are the people that we see potentially being able to derive the most value from it. And so we wanted to come up with something that kind of eased that entry into the FIA world, where they don't have to read the user guide front to back and really get into the database structure and the schema and all the field protocols and all that, but still be able to use some of the information that FIA produces because it is so valuable. Now, while doing that, we also didn't want to simplify it so much that you wouldn't be able to do everything that you want to be able to do with it. So we want to support our FIA analysts too, and other people who are kind of more the power user level of FIA, just to save them some time and some hassle from dealing with the database, but still have the flexibility to be able to do everything that they want to do. So that's what we tried to do here. And I'm just going to run through an example to kind of highlight the various functionality of the site. So this is it. You have some intro text here. We have a header where you can toggle between light and dark mode. You can open a help menu that has a guide, which is a PDF with just a bunch of stuff in it. And then there's also, those help resources are also linked in the intro text. There's also a tour that's just kind of slides that you can swing through. A contact button that goes to a feedback form, and then a link out to My City's Trees, which we see as sort of a sister site to Urban Forest Stats. Jumping in here, first I'm going to hide this intro because once you're familiar with the app, you probably don't want to see that every time. Once you hide it, your browser will remember and you won't have to look at it anymore unless you want to. The main part, the meat of it, is selecting basically your query, what you want to get out of Urban Forest Stats. And so the first thing is your geography and year. And in FIA speak, that is your evaluation. Now, again, our primary users of this are not from the FIA world, and so we are trying not to use terms like evaluation so that they understand, they have kind of more of an intuitive understanding of what they're doing here. So here you can select a geography, you can scroll through the list and pick, or you can start typing if you know what you want. And so I'm going to choose St. Louis here, and then you pick the year independently so that this list is not so massive. I'm going to pick 2022. Now, I may wonder, what does St. Louis mean? I mean, maybe I'm not thinking about that because it seems obvious, like, oh, that's probably the city of St. Louis. But if you have questions about what the definitions of these boundaries are, that's what we have these info buttons for. This is basic explanation of Urban FIA, but if you click the link, it opens another page with all these descriptions. So here we can see St. Louis is actually one of our
kind of exceptions to the standard of being the 2010 census boundary for the population area. And it includes both the city and urban areas surrounding the city. And so it's just good to know those little quirks. So we've got that. We have St. Louis. I'm going to look at the number of trees. And here we have another quirk of FIA and urban FIA. In urban areas, we have mother trees, which are the single organism, as opposed to FIA trees, which are the stems. And so here, live trees is the FIA definition. Live mother trees is the organism level. So that's what I'm going to pick. And then here for a summary category, which is a grouping variable, basically, I'm going to choose geography subdivision because I saw on the page talking about the boundary that St. Louis actually has multiple estimation units within, and no, it didn't use the words estimation units, but that's what these are. Subdivisions are the estimation units within the evaluation for you true FIA people out there. All right, so I have some selections. You'll notice I left a couple things blank. The summary categories are optional. I'm going to hit run. When I run, what is happening in the background is that the site is sending post requests to the Urban FIADB-API. So it's actually doing two, one for the population estimates, which you see here in this table, and then a second one for plot level values, which we'll get to in a second. Here, the first thing you get after you run is just a summary of what you selected up above. So you have it right there in front of you. And then the estimates. So here I just did the two estimation units of St. Louis, so the urban area surrounding it, 43 million trees, and then the city itself with 765,000. I can also view the sampling errors if I want to see, man, that proportionately is pretty different. What's the sampling error like? All right, we've got 11.3% on the urban area versus 27 in the city. Also, if you want to change how you are viewing the sampling errors, you have some options here. If you click on the words show sampling errors, you can choose to display that in the units of the estimate instead of a percentage basis, as we typically do with FIA. And then you can also switch the confidence level too if you want. So now we see, okay, plus or minus about 5 million trees in the urban areas and 200,000 in the city. A couple other things to point out here real quickly. You can export the table results to a CSV file. And if you do that, it will include whatever is actually showing right here. So if I have the sampling errors off, it will just be this. If I have the sampling errors on, it will include the sampling errors. And then the same deal with this icon, which will copy the contents of the table to your clipboard. So if you want to go do some work in Excel or some other program, you can just tap that and copy and paste. All right, moving down the page, the next thing we have here is a map. This, again, is what that second request was doing, getting plot level values from the API. And these are the unadjusted trees per acre for the plot. It's just a heat map, very simple density. So hot is more trees, cool is fewer trees. And here with the map, you also get your summary category as a filter. So if I want to switch off and just see the city of St. Louis, I can do that. And then I can go back to seeing the whole area. We've also got download options here for the map, which will just kick out those public coordinates of the plots with the TPA. next we have some information about the data. This is the same paragraph we saw on the info page about the geographies. So here again, I see that, oh, I can use geography subdivision to get at the city versus the urban area. And then just some more information about the different things we chose. References, as I've said, we're using the Urban FIADB API. And so we have the reference for it here. And then we're also using the user guide to write a lot of oh, well, not in this example. I'll show that in a minute, but a lot of the kind of metadata about the summary categories comes from the user guide. And then just for awareness, even though all of the estimation is actually done by the API itself, I did include the Greenbook and Greenbook 2 here, in case people want to get more into the details of how the estimates are computed. The last major section from the results is an SQL block. Here, you get some SQL that you can copy and paste and use in FIADB directly to replicate the query that you did here. This first option will work in like Oracle or Postgres or something like that. There is also an option to format it for SQLite. So if you go to the DataMart that Cara was just showing and you download the SQLite databases that are available there, you should be able to use this directly in those databases. Finally, we have a little recommended citation. That's something people always ask about. So we included that. And then down in the footer, some basic information about the website and links to some other resources. Again, My City's Trees, the Urban FIA main site, the Urban Data Mart that Cara was just showing, and also the Urban Owners Survey. All right, I want to show just a couple more things here. I'm going to switch over from St. Louis to Houston. I'm going to, again, you see you get the full cohort of evaluation years. I'm going to go with the most recent again, 2022. And the icon that I did not point out before, you click that, you get just kind of a snapshot report, a number of estimates from that evaluation, all compiled in one spot, easy to download, easy to share. And I will point out that it contains some ecosystem service values that are not yet available in this estimate list. And that's just because of the way they're stored in the database and computed. But they are going to be added at some point, and that addition is already in the works on the FIA side in the IM shop. So that will be exciting to get. Moving forward, though, if we say we want to do another query instead of live mother trees, we want to know about carbon in Houston. I can start typing carbon. I can do below ground and above ground, the whole tree carbon content. I can also do above ground and below ground and add on sequestration. And so you can see here, I can select multiple estimates. If I do that, then my row summary category is automatically going to be estimates. I can still choose columns and a repeater, which I will do to show you how that works. So I'm going to pick land use here and ownership group. And you can see that these are kind of organized by type. So things that apply to areas, tree size, other things about trees, and so on. So I'm going to run that real quick. And so now we see we've got our estimates here in rows. We no longer have a total row because they're not additive, obviously. We have the land uses going across as our columns. And then we have tabs with the ownership groups. And so we can cycle through those and see. And just interesting side note, if ownership is not available, it means it's on water. And you can see that very nicely here. So anyway, that's a quick example there. Let's see. I'm probably getting pretty close on time here. So for this next thing, I'm just gonna show that you can do this. And first I'm gonna open. Okay, so if I have an estimate, I want to filter it. I can do that in a few different ways. We have area filters, and we have a couple here pre-configured. So ownership group, you can just pick directly from a drop-down list, and same with land use. And then we have some other things that you can choose from too, like the condition status. So when we talk about area filters, we basically mean things that are condition level or plot level attributes, and they can be applied to any kind of estimate. Tree filters can only be applied to estimates that are based on trees. You can filter by diameter. We've got some options here for that, species, and then again, some other categories that you can choose from there. And then finally, for the FIA aficionados out there, we do have a custom SQL box where you can enter custom filters if you're comfortable doing that. If I want to, instead of doing like a normal standard estimate, if I want to do a ratio estimate, I can do that. And here, again, show quickly, if I do number of trees per acre, you can see I get some additional options here in the filters to apply to the numerator and denominator, or the numerator only. And then if instead of trees per an area estimate, I'm doing trees per trees. So like if I want to know the percentage that are a certain species or something like that, then those options also pop up for the tree filters. And I think I'm out of time. So I will close there with a final note of the feedback button that is ever present on the screen. And it is ever present because it is so important for us to know how to make this better and to build it into the future and give you everything that you need. Please give us feedback, and you can use that button anytime. Thanks.
Awesome. Thanks, Rebekah. I really appreciate it. Yeah, please, feedback is so critical for all these things that we're working on. We're building them for you users, so we want to know what you want and how to make them better. All right, with that, it's my turn to give this a shot. See how this goes. So, up until recently, well, let's back up there. Evaluator and the API have a lot of different options for spatial grouping. Say you want to do it by county, or you want to group an estimate by county, and you want to group an estimate by eco-region or eco-province or something else. You can do all that in Evaluator because those attributes are associated with plots already in the database. That makes it super easy to generate estimates based on those geographies. Say you have your own equal blob you're interested in now, and they don't line up with what is packaged in Evaluator. Up until recently, you could go to Datum's spatial intersection tool, and you could use that to run a spatial intersection, generating FIA estimates for your own geographies. Unfortunately, the spatial intersection tool and Datum were deprecated recently, and we don't have a good replacement yet. So I put together a workflow that is relatively straightforward or relatively easy to help people run a spatial intersection in case you have eco-blobs, geographies, whatever that you want to generate FIA estimates for. So this demo works really well on Teams, where you can share a monitor Here it's trickier because I have to share one application at a time, so we'll give it a shot. First of all, we'll start out with eValidator. So here we have eValidator, and I am just going to generate a general estimate. Say I'm interested in carbon in the upper Midwest, and this is the demo that I put together. And I do have a document. I've documented all this in a nice workflow. As soon as I figure out how to share that with you, I'll send that out. So don't worry about taking a ton of notes. You shouldn't need to. All this stuff will be documented and shared with you. And again, that said, I'm going to run through, and show you how to. So there, my screen's went back. Okay, I'm going to run through and show you how to do a spatial intersection estimating total carbon in the upper Midwest. So the first thing I'm going to do is I'm going to start just by generating a standard estimate. So I'm going to go and I'm going to grab total carbon, and I'm going to go pick the 3 inventories I'm interested in. Right now, I'm going to pick out Michigan, Minnesota, and Wisconsin, so I can get data for those 3 states. Continue. Right now, I'm just looking to get the plot information so I can grab that plot data and intersect it with my geographies. So to make it nice and clean, I'm going to pick eValid or eValID for each of my row and column variables, and that's something. This way, I'll make sure that I only get 1 record per plot for every plot in this estimate. So once I get it all set up, I've got carbon, I've got my 3 inventories, I'm going to hit open a new window. Now this is where we find out, or we start to really leverage the power of the API, because the eValidator is really just an interface for the API. What it does is it builds URLs. So here we have the URL that has all the options that I selected there. I've got my 3 inventories, 26, 27, 55. That's Michigan, Minnesota, and Wisconsin. I've got my estimate here, total carbon, number 7. Got eValid for my row selected and eValid for my column selected. And sure enough, here's my estimates. Now, because all of these are just URL parameters, I can take those and I can edit those and I can add to those. And what I'm going to do now is I'm going to add 2 extra parameters here. I'm going to add one to say plot data. True. So this is what this is going to do is this is going to tell the API to return, instead of summarized estimates like this, give me an estimate for each plot included in this summarized estimate. You can see there's 35,000 plots total of those. So 16,000 are forested. So we should get around 16 or almost 17,000 records back from this. The other thing I'm going to do is, because that's huge and I don't want to have to really deal with it all here in the HTML screen, I'm going to tell it to tell the API to give it back to me as a CSV file. So I'm going to put output format equals CSV. Hit enter. How much of this you guys will actually be able to see? I don't know if you can see that, but it's prompting me to save a CSV file. I'm going to go ahead and do that. Okay, my CSV file is saved. I'm going to switch now to a different program. Okay, so here are the eco blobs I'm interested in. This is just a terrestrial ecoregion layer that I got off of the F3 Living Atlas. I just wanted to find something that was blobs that weren't in FIADB that I could play with. So here we have a couple of ecoregions that span the 3 states. We've got the mixed wood shield, the mixed wood plains, central USA plains, temperate prairies. What I want to do is I want to add the data, and then I want to associate each of those plot locations with one of these ecoregions. So I'll come here, I'll look for my data, I'll go and I'll get the CSV file I just downloaded from the API. This worked. But again, I see what I did. Add data, I have to hit refresh. But this is hard. There it is. Okay. So here's my data. Here's my CSV data. I can open it up and take a look at it. That's everything I just put out of the API. You see, I've got my plot CN here. I've got my lat longs, and I've got my value. I'm less worried about the value for this as much as my lat long and my plot CN. Because what I want to do is I want to change this from just a CSV table to points. To do that, I'm going to create points for the table. I'm going to use this XY table to point tool. I'm going to make sure my X field is long, my Y field is flat, and down here in the coordinate system, I'm going to type add 1983. And it luckily knows to fill it in with GCS North American 1983. That's the proper coordinate system for FIA public qualification. So I hit that, okay, hit run, and boom, there's all those beautiful FIA plots for the inventories that I selected. A bunch of them there. Next thing I want to do is I want to run a spatial intersection. So I'm going to add a spatial join. I've got my XY table to point layer there. I'm going to grab my level 2 ecoregions. I just want some of the fields from those ecoregions. I don't want them all. So I'm going to come in here and I'm going to edit the cluster. So I don't have to deal with to kind of wade through all of that data. The one I'm really interested in here is the L2 key in English. So that's just the these labels here. The ecoregion name in English. I'm going to get rid of the other ones. Hit OK. And hit OK to join that data to my point. So that's running. We've got the spatial intersection. Now we should have my attribute table here. And I scroll over to the side. Bingo. We've got associated with each of these plot CNs. Now I have a ecoregion category. Now, the only issue is there's a couple of these that fell outside. And because the API is not going to like it if I have some blanks here, I'm going to have to fill out those blanks. Now, I can't fill out blanks on a join table. So just real quick, I'm going to export these features into a new feature class. Again, let it field so I don't have to deal with everything that I don't want to. What I'm really interested in plot CN in this L2 key English label. That's what I want to grab and take and push back to the evaluator. So I'm going to remove everything else, keep those, hit OK. And so here's just the plot CN and my L2 key. Now I have to select and fill in that L2 key. Make sure there's no null values there. Yep, 28 of them. So I'm just going to calculate real quick. I'm going to tell that to say no eco V. And that's okay. All right, so now I should have no null values. I'm going to clear my selection and I'm going to export this back out to a CSV table. We go data export table. I'm going to add or go and play with this fields option again. I'm going to add an empty field. Now this seems weird, but I'm going to add an empty field because it helps me format this in the way that the API is expected. And that's with a comma between every record. So I'm just going to make an empty field and call it comma. And this will make sure that when I export this into a CSV file, that's a comment before every line. And I'll show you what that means for in a second. So the other thing I want to do is I want to make sure I export it to a CSV somewhere where I can get to it. Demo here, so I'm going to say by API estimates. So how about I do once, like that. And hit OK. So now I have my ecoregion plots, and I'm going to go and I'm going to see if I can open those. I'm going to open those with in a text editor. So I'm going to open those with WordPad, and I'll show you that looks like. Okay. Here are all those records in WordPad. You can see I added that comma field that gives me this trailing comma here at the end of every record before the line break. What I want to do is I'm going to go through and I'm going to copy all of these. I'm going to skip the header. I'm going to copy everything but that last comment. So this is a huge long list of plot CNs and ecoregion assignments. Ginormous. So I'm going to go copy all of those, and then I am going to go back to revalidate. So I'll do that real quick. So I can share with you. Since the validator will probably have timed out by now and won't remember my previous selections, I'm going to go back to this and start my estimate over. What I was interested in, again, was carbon. So if they click on that, and I'm going to go for total carbon in short tons, continue. I'm going to pick the same states I was interested in, Michigan, Minnesota, and Wisconsin. And here's where I'm going to choose, instead of eval as my row variable, I'm going to choose forest type to give you the answers back in forest type. And we have these awesome little boxes here that allow for users to enter their custom page row column grouping functions for plot CN value pairs. And so we have a giant list of plot CN value pairs. I'm going to paste that right in here. It's a whole big giant list, all fits in there. Now I can click Open Estimates, a new window. That's going to give me a JSON response, which is going to be really hard to read. So I'm going to go ahead and click on download normalized estimates as a CSV. It's going to work on this for a while, and then I'm going to be prompted, once it's generated the estimates, I'm going to be prompted to save this. Second, the other option you can do is you can go to our DataMart website and you can generate estimates using custom page row column groupings the same way as you can in Validator, only you do it through the batch workbook. To find a batch workbook, you come to our DataMart website, you click on XLSN, you choose a state. I'm going to choose Minnesota. And I can come here and I can click on that. I can download, prompting me to save the estimates I just created. I'm going to save those. But if I click on this, I can download the workbook. I'll save that as Minnesota XLSN. Here, I will go ahead and just open up and show you the estimates that I got. All right, so these are the estimates that evaluator just picked out and gave back to me. You can see if I scroll down, here are all of my custom ecoregion estimates. So for all three states in the mixed wood shield, we have that much total carbon, whatever that number is. We've got the variance plot counts, sampling error, and sampling error percent there too. The other thing we have, or the other thing I want to show you is this. So this is that batch workbook I was talking about. If you go in here, these batch workbooks are all available preloaded on DataMart. But just because they're preloaded doesn't mean they don't work or you can't customize them. What I encourage users to do, if they can't get something to work in eValidator, is to come download one of these workbooks and start making changes to it. These workbooks just kind of work through all the estimates that are lined up in this inputs table until it hits a blank space. So I'm going to put a blank space right there. And now it's going to stop, or it should stop after the first three estimates. If I scroll all the way over to the right-hand side here, you'll see I have, just like I did in the validator here, I have options for entering custom row column, CN, and category pairs. I also have an option where I can point directly to a file name. And then if I hit, go back and hit query, and I'm not going to do this right now because it's going to take too long and I want to give Alex time. But if I were to put those column CN category pairs in here or point it to the right file, I can query and it will go through and automatically reach out to the API, submit the query, come back and populate the 3 new tabs with data. So here's the premium estimate tabs. With that, I am going to talk to the C9 up my time limit and hand it back over to Alex.
Alrighty. Thank you so much, Jim. What a great presentation. Alrighty. Good afternoon, everyone. So as we've been hearing about this Urban Evalidator API from all the lovely talks today, I'm going to talk about one more way that you can access the Urban Evalidator API, and it's through actually accessing the endpoints in R. We're going to look at some website endpoints first. We're then going to do some live example in R just to see what it looks like. Rebekah pointed this out on the Evalidator FIADB API urban endpoint. You have this lovely documentation, and I wanted to point out kind of what's going on behind the scenes for all the things that Urban Forest Stats make so easy. It's really an incredible tool. So kudos to the Texas A&M team for Urban Forest Stats and all the work that went into it. But when you're selecting a geography, you're accessing this endpoint of the FIADB API. And so here's where you could pick your particular eval ID, and you can get some more information about what is included in that estimate. In a similar way, one of the other drop-down selections in Urban Forest Stats is the estimate. So Rebekah mentioned, are you making an estimate of annual fuel use avoided or basal area of live trees? The last endpoint I'll be talking about is the grouping endpoint, GRPS, where you can group your number of live trees by FIA land use, as an example, and it has information about what's actually happening behind the scenes to produce that estimate. And now I will switch to R to showcase what this looks like in terms of accessing the API directly from a coding or programmatic location. All right, so we're going to load a couple of the libraries, and we're also going to load this function into memory. I should say that this example of how to access the R post is available in the Urban Evalidator documentation, so you can find this code available online. But for our live introduction, we have gone through our endpoint introduction. So we can read in the geography, the SNUM, and the grouping endpoints into your local environment, so that you can access whichever row of that endpoint that you would like to have access to. So in the R environment, and up here we have this function that does the sending of the request from your local machine through the internet to the API, and that's the same kind of request that Urban Forest Stats does when you select run this estimate. Just to show you what this looks like, you can access the object with indexing. So these are all of the evaluations or the geographies that you could possibly enter into the API. By running this, the SNUM, the estimates, you can see all of the possible, for example, leaf area is number 22, all of the possible estimates you can make. And then there's also groups, which you can access, and you can see all of the possible grouping variables that you can access to do a combination of this estimate with this grouping in this city. So this offers some flexibility that's more on the power user end side of things that I'll be happy to talk to you more about. So just for as an example, we can access the 22nd row of the SNUM endpoint is currently leaf area for iTree. It's an iTree variable. We can also access the grouping data frame number 33 is ownership. So to put this all together, we make an argument list. So we're going to choose Baltimore, Maryland, 2022, CUR as our eval ID in the geog. We're going to choose our estimate. We're also going to choose our grouping variable. And so just to show you, this is just an estimate grouped by ownership. How much leaf area is there in Baltimore? So those are our arguments. Our argument function is this FIADB-API post. And you can see just now I made a post data object. And this post data object, if you just look at what the outputs are, one of the outputs are estimates. So this is the table you would see in urban forest stats, but it also includes a total estimate. It also includes metadata for what was used in this particular post request. And for those of you who like to get into it, there's also the SQL and SQLite that are provided as part of this post data object. So you can see there's this SQL request that was put to the FIADB public database is right here. And also there's a SQLite code that's available. Okay, so that's just the endpoints. You have estimates and groupings and also different geographies. But let's say we want to make different combinations happen. So just to point out, FIA land use as a grouping might be of interest. It's number 18. The species grouping is number 27. So part of the power of this kind of scripted API interface is you can select what combinations you would like to see, and then makes it very easy to create an output table of those values. The extension of having the ability to make various estimates is you can bring it into your visualization program of your choice. So for example, here is a distribution of leaf area and what percent of the leaf area in Baltimore you can find in each land use category. If we wanted to update this and say, maybe we want to look by ownership as opposed to by FIA land use, well, we know that ownership is number 33 in terms of the group argument. We just need to update the G parameter to level 33. And so this G is going to be used right here in this groups argument. We're going to keep the same numerator and the same Baltimore evaluation. But if you wanted to update your graph, it's as simple as making one change, and you can now see, you hopefully should be able to see what you're looking at. So yeah, FIA land use, my apologies. Looks like 18 is land use and G is 33. Yeah, I'm not sure why that didn't produce the ownership. That's what happens in a live demo. Let's do it again. So yeah, we do have our ownership data here, and we can update to look at leaf area by ownership. My last example is just to look at it by species groups, just to show an example of how easy it is to view different estimates. And if you wanted to make a for loop for all of the cities at once and make the same kind of examination from the unified source of estimates, this is just another avenue that one could use to do this. So as the last graph, I'll look at species group, setting G to 27. And this will update the information to give us species group level leaf area in Baltimore. And with that, thank you very much. Happy to take any questions or talk more broadly about this session that we've learned so much about. Thank you.
Excellent. Thank you, Alex. All right, that brings us to the end of our presentations. We've gotten to see some exciting new data and applications. We've gotten to see a whole bunch of really fun ways to interact and leverage the power of the API to access and use FIA data. Anything else that anyone has questions for? We got about 5 minutes left on the session here. We're getting some kudos here, guys. So good work to all of our presenters. I'd like to take a second to thank you all again. Really appreciate everything that was presented here in the session today. Anything else? We are all, well, aside from Cara, unfortunately, all of the rest of us are always available to answer questions. Feel free to reach out to us, and happy to help you figure out how to get the data you need, how to use the application you need, and how to basically do the fancy things you want to do. And with that, I guess I will sign off. Thanks so much to everyone for participating and listening to our presentations.